Hi, this video will show you the advantages of CADWIND's non-geodesic winding algorithm over normal helical winding or geodesic winding. The non-geodesic winding is based on physical modeling of the friction between fiber and mandrel, so it gives a very accurate simulation of what will happen in real life. We will start by creating a pipe mandrel. Our pipe mandrel will have a circular cross-section. It will have a diameter of 300 mm, a length of the center section of 4000 millimeters, and 1000 millimeter extensions at each end of the pipe. And we'll use 100 equally spaced frames. We'll give our pipe mandrel a name. And you can see in a matter of a few seconds our pipe mandrel is ready to go. This is a fully three-dimensional model of the mandrel, so we can rotate, pan and zoom in and zoom out on the mandrel just like you could in CAD software. Next, we'll set the material parameters for the winding. We do this in the winding menu, material. In this example, we'll be using 8 rovings with a width of 5 mm each, making a total bandwidth of 40 mm. We'll use a fiber volume content 57%, a text value of 800 grams per kilometer, and fiber and resin densities of 1.77 and 1.2 grams per cubic centimeter, respectively. Firstly, I'll demonstrate a normal helical winding. You can see that there are only a few parameters to enter for a helical winding, which makes the winding very easy and fast, but doesn't give many options if you want to do anything out of the ordinary. For this demonstration, I'll use a 45-degree winding angle with a 4 pattern number and a 1 skip index, and we'll close the winding pattern in the turning zones only. Now that we can see the winding pattern on the mandrel, I'll take a couple of minutes to explain some of the issues of winding calculation in general. Firstly, there is a need to close the winding pattern. You can see that each cycle of the winding must finish in exactly the right spot to begin the next cycle. Like this, the fiber bands end up side by side, and every part of the mandrel gets covered in exactly the same way as every other part of the mandrel. If this were not to be done successfully, then some areas of the mandrel would be covered many times and other parts of the mandrel would not be covered at all. To achieve this, using helical winding, CADWIND gives you CADWIND must make some adjustments to the fiber path so that each cycle ends in exactly the right place. You have some options here about where we can make that adjustment to the winding path. Either change the entire path, in which case it will make a small adjustment spread out over the entire path. You can make the adjustment in the turning zones only. That is the areas at the end of the mandrel where the fibers are turning around to return. Or you can tell CADWIND not to make any adjustment to the winding pattern at all, in which case you are a little more limited in the pattern numbers that you can successfully wind. The other issue I would like to talk about is fiber slip. You can imagine if CADWIND were to try and turn the fibers at the ends here too sharply, that they would slip in towards the middle when they were pulled tight under tension, as they usually are during filament winding. This messes up the winding and is generally something you want to avoid. However, with helical winding there is no guarantee that the fibers won't slip, as there's no calculation performed to check this. This is one of the reasons that non-geodesic winding was developed. So, if we were to do this winding using the non-geodesic winding algorithm, we would see that in addition to the winding angle and other parameters, we also have the friction factor parameter. That's because the non-geodesic winding actually performs friction calculations between the fiber and the surface of the mandrel and makes sure that the friction stays within the physical limits that you set using this parameter. That effectively guarantees that there will be no slipping as long as you use a friction factor that's appropriate. So I'm going to enter the same parameters that we did for the helical winding so that you can see that we should get a similar result. Using non-geodesic winding, there's no adjustment to the fiber path in the turning zones or anywhere else in order to close the pattern. So non-geodesic winding, if you use non-geodesic winding, you're not always guaranteed that you're going to get the pattern number that you necessarily want. That's because non-geodesic winding is a physical modeling of what's actually happened, so it will only allow you to create winding patterns that are physically possible without fiber slipping and without exceeding the friction limits that you've set. So I'm going to choose a pattern number from this list of possibilities and we'll wind that instead. You can see it's quite similar to the helical winding that we did before, just a slightly different pattern. Aside from avoiding fiber slipping, non-geodesic winding has the advantage of opening up a huge range of new possible winding paths. For example, using non-geodesic winding, we can make changes to the fiber angle in the same winding path. So, for example, if we wanted to vary the winding angle from 45 degrees to a higher angle, say 70 degrees in the middle of the winding, we can simply change the winding from constant to variable, set a 70-degree desired fiber winding angle in the frames in the middle of the mandrel. In this example, I'll say between frames 40 and 60. We can also adjust the positions of the turning zones. We have much more control over the turning zones using non-geodesic winding. So we'll make the front turning zone a little further to the left and the back turning zone a little further to the right. And that way we should cover more of the mandrel. So adjust the starting frame so it remains at the beginning or at the end of the front turning zone. When we're happy with all of that, I'll click Start Winding. Again, we'll have to choose the pattern number from a list of possibilities. And in a few seconds you can see our winding on the screen. I'll give you a top view of that. Zoom in. And you can see this area in the middle here has a much higher fiber winding angle than the 45 degrees angle at the sides. If we use the color scale, we can show that very clearly. So I'll set the scale at the bottom here to be between 30 degrees and say 80 degrees. You can see very clearly then that the zone in the middle here is a bright orange color, indicating that it's winding at 70 degrees, whereas this light blue colors at the end is indicating that we're winding at a 45-degree angle. This wouldn't be possible with helical winding. You'll also notice that we've covered more of the mandrel in this winding because I was able to adjust the turning zones to be closer to the edges of the mandrel. Again, that's not possible using helical winding. You must use non-geodesic winding to do that. Another interesting phenomenon I'd like to point out quickly using the color scale is the laminate thickness. You notice that where we've increased the winding angle in the middle here, the thickness of the winding is significantly higher than where at the 45-degree angles closer to the edges. This is a physical phenomenon that CADWIND does quite a good job of analyzing using the color scale. The last winding path possibility I'd like to share with you that's made available by non-geodesic winding is the ability to wind around pins. We can vary the friction factor and put in a very high friction factor in the last few frames, In this case, the frames from 1 to 15 in the front turning zone will set with a friction factor value of 2, and the frames from 85 to 99 in the back turning zone will also set with a friction factor of 2. You notice the friction factor in between remains 0.15 like before. This should have the effect of turning the fibers very quickly once it gets to that turning zone at frame 85 and frame 15, which is perfect for simulating the winding around pins. Again, we'll have to choose a pattern number from the list of possibilities here. This first one looks as good as any. You can see the fibers are turning quickly at the ends, which is perfect if you have pins set up on your mandrel. You want to reduce wastage by eliminating the long extensions at the end of the mandrel. I'll just play the simulation of the winding there, and you can see how quickly they're turning. This is only possible using non-geodesic winding again. So, we've reached the end of this video. In summary, we talked about the difference between non-geodesic and helical winding. Non-geodesic winding models the friction between the fiber and the mandrel, where helical winding is not. This eliminates the possibility of fiber slip, provided an appropriate friction factor is used and all parameters entered into CADWIND are accurate. It allows the ability to alter the winding angle along the same winding path. It allows more control over fiber turning zones and fiber turning. And it allows the use of pins, which dramatically reduce the turnaround areas, which are basically wasted, cut off and thrown away when winding pipes. Thank you.